Hey everyone, in this video I want to talk about passkeys because today you can't look at any computer related site or even national media without seeing passkeys. And so what I wanted to do is dive into what a passkey is, why we needed it, and then some of the specifics around the Microsoft ecosystem and how I could use them with Entra tenants and even Microsoft accounts. If we go back through time, we started off with passwords. And although these are terrible and evil because they're a network secret, which means if I know it, I can use it anywhere, they're at least something that, honestly, the average person understands. Hey, I want to go and use something. I need a username and I need a password. But they're just inherently weak. And so then what we saw was we would add to this. For example, there was things like one-time passcodes. Maybe we get texted something and then we type that in. But there were challenges with that. It can be exploited. And then what we saw in the industry is we had FIDO. And if I talk about FIDO, I'm really talking here the V1. And this was based around having a second strong authentication. So I still had a username, I still had a password, and then I would use this fob to do a stronger authentication. And we'll come back to that. And then we had things like the Microsoft Authenticator app. So if I think about my Authenticator app, and what we had here was a native solution by Microsoft. And what we could do initially, you would just kind of tap yes. And then you had things like MFA fatigue, which was a problem because people would just keep tapping yes. So you wanted to snap their attention and make them have to do something. So then it was, well, you have to type in this number, which also made them more resistant to someone just tricking them. It would give you context. It would show you, well, which app was trying to use it. It would show you a location. But the challenge is you were still susceptible to phishing. And if you look at strong authentication methods in sort of the Entra portals, if we actually jump over super quickly, if we go and look at authentication methods, and if you were to look at authentication strengths, you'll see there are these ideas of different levels of authentication. And we have sort of passwordless MFA and then phishing resistant MFA. And passwordless MFA would include the Microsoft Authenticator app. So it's like, okay, great, I'm going to use that. But if you looked at phishing resistant MFA, it does not include the Authenticator app. It's Hello for Business, it's Passkeys, funny enough, FIDO2, and certificate-based authentication. So why, when we look at this, is the Microsoft Authenticator app not considered phishing resistant? And it's because it relies on a human being, their cognitive awareness to detect, hey, something's not quite right. So to demonstrate that, I can think of the idea that there's some site. And what we have in here is the bad person. So we have them on their machine, and we have the evil person. So this is the evil. And what they want to do is talk to that site as another user. So then we have the nice, happy user over here. They're very nice. And they have their Authenticator. Let's say it's Authenticator app on their phone. And so what happens is when the evil person talks to the site says, okay, I'm going to give you some challenge. Now that challenge could be you have to type in this number on your Authenticator app. And so the app would have been prompted. Say, hey, you need to type in this challenge. And this is where the evil person can use social engineering. They phone up the user and say, hey, I'm from the IT department. We've seen something weird happening on your account, but I first need to prove you are who you say you are. I'm going to send you a challenge. So I've sent you a challenge. Now, they got the challenge from the site, and it says type in number 56. Hey, user, remember I'm from the IT department. To prove you're the real user, I need you to type in 56 to this challenge. Oh, okay, I should probably do that, says the nice user who trusts people. So they type in 56. They've now passed the challenge. And now what happens is, well, the authentication is complete. So it creates whatever token and gives it to the bad person. The user has been phished. That's really the whole challenge here. And that's happening fundamentally because if we look at this, what is this missing? There is no check here that there is presence. There is no proof of proximity. And so that Authenticator app that the user has could be hundreds of miles away, could be the other side of the planet, could be on Mars if different people get their way, and the evil person's nowhere near it. So there's no check for that presence. There's no check for that proximity. And so it's susceptible to be tricked to say, yes, approve this. And that's not the case for the other things we saw. If you saw the 3 that were allowed, well, hello for business. That TPM is in the machine that I'm performing the access from. Can't be tricked to use it on a remote machine. Certificate-based authentication, that certificate is in a smart card that I insert into the machine. Can't be tricked. The passkeys, now again, because they've changed the terminology, it used to be like FIDO2 key, but now these are just all passkeys. Historically, I would think about something like a USB that I would have to put into the machine and some gesture, a thumbprint, maybe a pin. It has to be present in the machine. So those can't be phished from the perspective of tricking them to do something remotely. And that's the whole point about why the Authenticator app is not considered phishing resistant with its native things that it does. Those phishing resistants have that proximity check. So to be phishing resistant, I can't be susceptible to social engineering. I need that presence of the authenticator. I need that intent from the user. And so that's where we now get to the idea of passkeys. So as we go through and continue our timeline, well, now we're here. So we have the FIDO2. So remember, FIDO is an alliance. It was created many, many years ago. Fast Identity Online. And they initially developed this FIDO v1, which was this universal second factor. And it's all built off PKI, as is the new one. So the whole point of the PKI, remember, public key infrastructure, there's a private key and a public key. So in this idea, the site I was accessing, well, they would have the public key. And then the account, which whatever authenticator I'm using, well, the account has the private key and never, ever shares that. So that private key, and if I think about that universal second factor, and we really had those idea of the different types of key fobs, that private key lived on that fob. And so we'd have to insert it into the machine to use it. We'd unlock it doing something that provided that very secure second factor. And PKI is used everywhere. When we use TLS, HTTPS, it's all using PKI for those various validations and the encryptions. And so we're still doing this here, but what FIDO2 has done is expand on this. Other organizations joined, including Microsoft, and worked on expanding the technology to be applicable to everyone. Because these fobs are great, But there's challenges as you try to get a wider adoption. Like the average consumer does not want to carry a fob around with them. And if you look at modern hardware, modern PCs have TPMs in them, which is what Windows Hello is using. Your modern phones, your iPhone, your Android phone, they have hardware cryptographic capabilities. So the goal is to enable a platform authenticator that's built in, that's part of the machine. And then I use the platform's native capabilities to unlock it, be it biometric, a thumbprint, a facial scan, or maybe it is just a PIN. And then it makes it far more applicable to far more different scenarios. And that's where we have FIDO2. And specifically what we're talking about here is, let's do a new color, is passwordless FIDO2, which passkeys. And I actually want to be a little bit careful. It's not an uppercase P, it's just passkeys. But this is everything. So if you hear the term FIDO2, authenticator key, passwordless, that is passkeys. Fundamentally, research showed that the average person struggled with the idea of FIDO2. It was kind of a complicated term. And so it was agreed that for people to understand and associate it at a more simple level, passkey. Because the average person understands passwords. Hey, I've got a username, I've got my password. The average person will be able to understand, hey, I've got a passkey. I'm using a passkey for this site. And that's really, I think, the goal around where this terminology came from. But for the most part, the passwordless FIDO2 key is the same as just a passkey. Now, how is this actually functioning? And it's functioning using that same idea of PKI. That is still driving everything we're doing. But now it's this single step, strong multi-factor authentication. So, okay, let's dive into the passkey. So again, it is still PKI driven. That's a core part of everything we're doing with these passkeys. So we still have PKI as a huge building block to everything we're going to do. And we have the same components to make up the story. So I want to access a site. So I have the site. Now, in terminology, we're going to call this the relying party. So that relying party is the site that's offering the website, the service that I want to use. Now, I'm going to be accessing that from a certain client. So I'm using a client. And because this is all web-based, when I talk about client, I'm really talking about a browser. Now, I may have other types of applications, but what you'll see is they'll typically open up a web page to perform the authentication component of that. And then I have my authenticator. Now, remember, the authenticator can be many things. But me as an account owner, I'm using a certain authenticator. Now, I might have multiple authenticators. I might have a phone, I might have an iPad, I might have my desktop computer, I might have, hey, a USB key. The point is, me as a particular owner, I have certain authenticators that I leverage, and a particular passkey will be utilizing a certain authenticator. So I've got my authenticator device. So where the PKI now comes into this is when I go and create a new passkey, my authenticator will create the public key and the private key. Now, the private key will never, okay, it stays private. I was going to say it never leaves the authenticator, but that's not true because we do have a synced capability. But it's kept very private. So I have the private key. The site that I've created the passkey for, it'll be a separate passkey for every unique site, every unique account. I give them the public key. So this particular site, when I went and registered for a passkey, I sent them the public key. And they now know, hey, look, this public key is for a certain account. So that's account John. So now we have the components we need for PKI. The owner has the private key and they're keeping that secure. The other site has the public key, which again, it's a public key, nothing particularly super secret about that, not something I'm really challenged about. Now, when I want to authenticate, there's going to be a challenge. So I'm on a certain client, and now what's going to happen in the process is I'm going to be on my client, and to that relying party, that site, I'm saying, hey, I want to authenticate. Now, it could be this is the first time, and I actually want to go and set up a new passkey, but the overall flow is actually the same. So, hey, I want to authenticate. They're going to say, either we'll go and create a credential or go and get me a credential. But they're going to send me something called a nonce, not used more than once. So they're sending me this nonce, and that stops replay attacks. So it's always going to be this unique number. So then my client sends that the authenticator. So they're forwarding that nonce on. And now what can happen is, remember this has the private key, or again, during a generation, it would generate a private and a public key, but it can sign that nonce to prove I have the private key. So now that nonce has been signed. Now I can send that back, and because it's going to match, because you can reverse private and public key. So if it was signed with a private key, I can prove, yes, that actually you have the private key because I can decrypt it with the public key. Hey, I can validate that, and maybe there I go and create a token that you then go and use to do other things, to go and interact with whatever service I want to do. So this is the flow. And a key point here is, so I'm performing this cryptographic operation, so it's the PKI. But as part of this act right here, so when I want to use the private key as part of this specification, I have to have intent and I have to do some proof. So I think about, it could be a biometric, it could be a PIN, and I have to have intent, i.e. I'm doing some gesture. Because think about biometric facial scan, I may just walk past it. That doesn't mean I want to actually perform authentication. You'll sometimes see in hello that it'll see your face, but you still have to then swipe up. You have to prove your intent to do the thing. So as part of this flow, it's, hey, I want to authenticate to you. Okay, go and get the credential you're going to use. Here's the nonce. Okay, I want to sign it. Before I can sign it, hey, do you want to use your passkey or do you want to generate a new passkey? I use whatever that platform, whatever the authenticator has, facial scan, fingerprint, PIN. I prove my intent. I want to do this. I do some action. Then it uses the private key to sign that nonce. Then it can forward it over. It can decrypt the signature. It matches the nonce value. So I know they have the private key because it corresponds to the public key. I've now done that authentication. And the other thing that's critical for this to work and is required is between the client and the authenticator, I have to have presence. I have to have proximity. This cannot be on the other side of the world. And different technologies prove that proximity in different ways, and we're going to talk about that in more detail. So a USB device, cable only goes so far. Near field communications, NFC, only goes so far. Bluetooth only goes so far. So there's ways to prove I have that proximity, and that's a key part. So those hardware sensors, these other protocols involved, confirms I am there. There's always that proximity element. And it is multiple factors, remember. I have this authenticator device, so it's something I have. And then it's something I am or something I know. So it is a multi-factor strong authentication that's going on here. And that's everything. And that gesture is part of the promise that goes into this whole protocol. That's part of the passkeys. So remember, Windows Hello, my facial, I have to swipe up to do something. It's a user-friendly ceremony that triggers those very deeply secure cryptographic operations. But there's always that friendly user ceremony that is a core part of this. It can never be accidental. There's always a proof of intent from the user that then allows the complex stuff underneath to do these cryptographic operations. So there's always the promise bound to everything this does that there's a user gesture to prove that intent. And where I perform that gesture is always where the key is stored. That's a key point. I wouldn't perform the gesture over here and the key is there. The gesture is always done on the same device as where the key. And so the whole point is securely letting the hardware do the talking for me. That's everything we're doing as part of this. Now I glossed over a few things. So let's look at this in a little bit more detail, because I definitely missed some things out here. So I talked about the user wants to log in. And again, it could be the first time, which means I have to go and create a credential. But let's assume there is a passkey. So what actually happens here, when I say, hey, I want to authenticate with my passkey, this is happening over HTTPS, for one thing. So it's using TLS. There's a certificate that proves this site. So remember, this site has a URL. It's part of a certain fully qualified domain name. And that certificate has to match, or the browser's going to kick it out. Hey, this cert doesn't match who you're talking to. So there's a certain guarantee there that, hey, I'm really talking to that site. Now, I drew the client and I drew the browser, but also as part of the client, there is a WebAuthn component. And that is what is actually talking to the authenticator. Now, this is now very much a standard. So obviously Windows 10, Windows 11 has this. A lot of the mobile platforms have this in the browsers. But WebAuthn is really half of what the FIDO2 specification is doing. WebAuthn is what's doing all these cryptographic operations that's saying, hey, I need this nonce, I need this signed. This is everything. And so when I talk about, oh, this nonce being generated, this is part of that WebAuthn. So the browser is really just passing it to the WebAuthn client, who then goes and talks to the authenticator and does these various things. Now, because this site, this relying party is a URL, well, that relying party actually has a relying party ID. It has a name as well, but really the ID is a really important part. Now, this could be something x.com, whatever I want it, whatever it is for me. But this relying party ID, that domain name, has to be a subset of the URL. So that must be the case. i.e., I can't be a relying party ID of microevil.com and I'm part of the URL is microsoft.com. It has to be a subset of it, and that's going to be part of our phishing protection. So it's always part of the URL I'm visiting. It has to be part of that. So that's going to stop some of that spoofing going on. And that actually is part of the checks. So when I get these requests, my WebAuthn client will actually check. So as part of this, the WebAuthn client is going to do a check. It's going to say, okay, I'm talking to this site. Now remember, the user may have been tricked. I'm actually talking to Microsoft Evil. And they're telling me, hey, sign this, because they're trying to do a man-in-the-middle attack. Use a passkey for Microsoft.com. The WebAuthn client will check the URL and the relying party ID, and they have to match. So the relying party ID, so they're going to check the URL I'm currently talking to and the relying party ID. And they must match. If that relying party ID is not a subset of the URL I'm talking to, then it's going to kick it out. So it's giving me that protection from those types of phishing attacks. There is no transferability between different origins. So this is the origin, the relying party origin here. I can never use a passkey for one relying party to another relying party. Zero transferability. I cannot be tricked. Now I can trick users. Hey, this site looks a lot more, instead of it being Microsoft.com, it's micros0ft.com. A user may not notice that. This will always notice that. So this will help protect the user. There is no reliance on human cognition and noticing, hey, do these sites actually match? This cannot be tricked. So it's going to help protect against those person in the middle types attacks. And likewise, the relying party will validate. Hey, is this actually the correct passkey for my site? So it's going to make sure what you're giving me matches. So there's checks going on in all of the different levels. And what's actually happening here is when I say, hey, I want to authenticate, the relying party is like, okay, I want you to run this request for me. It says a navigator.credentials.get call. So what it actually is passing back to me is some JavaScript. And that JavaScript says, hey, run this get call against your WebAuthn client, pass it in the nonce, and then it will say, hey, which passkey do you want to use? So humans involved in that, they have to do those gestures, they have to do the unlock, they have the intent. I'm going to prove the proximity. It does the signing, it passes it back. All of these checks are going on to make sure spoofing's not happening. And then, hey, I've done my authentication. Now, if there isn't a credential already, if I don't have a passkey, it really works a similar way. But instead of this get, it's going to be a create. It's still going to pass me a nonce to stop replay attacks. But here I would generate that private and public key. I'll still sign that nonce, but now I'll send it back with the public key. They'll go and store it. And now I have that passkey. So the platform is doing all of the work, not the site. The site just has to store this public key. That's really all we have to do here. So before we go any further, let's just look at this again. And if I think about some of the challenges we have with phishing, with social engineering, what do we have here that can help? So can someone easily or at all trick me into performing an authentication for the bad person's device? No, because I have that proximity check. The bad person can't be on a machine hundreds of miles away or halfway around the planet and get me to do that gesture and have that intent on my authenticator to work with their device. I have to be very, very close. So it protects me against that element of the phishing. So I can't phish that proximity part. Can't be on the other side of the planet. What about trying to trick me by redirecting me to another site where it would then go and harvest a credential and then replay it somewhere else? Well, remember, if I was directed to the wrong site that looked like Microsoft.com and it just had a 0 instead of an O, they'd copied all the images, it looked exactly the same, and I'm fooled, I'm like, okay, I'm going to sign in, but the WebAuthn client is checking the URL I'm talking to, and then the relying party ID it's telling me to use the passkey for, they won't match. So I can't phish that element either. I can't try and trick the site. I can't try and trick the proximity. Now, I'm never going to say you can't be phished. There's always other attack vectors. There's always new imaginative things bad guys will do. But it gives me a lot of protection from some of those most common things that we see as that vector for the attack today. What about the site? Remember, historically, we see, hey, a website gets attacked and hacked and they steal and harvest the credentials. Well, what does the site now store? The site now stores a public key. So from a credential perspective, hacking is useless. Now, they may be storing other information about you, social security numbers, phone numbers, that is not useless, but from a credential perspective, they can't steal your credential anymore because it's not here. We're using public private key cryptography. They have nothing of any special value. This is the important part over here. So the hacking becomes useless from a credential perspective. I have a private key, but there's no password. So that's really good. Now that I'm not going to go and use the same credential on different sites, if one is broken, the others are broken, it takes away that complexity from a user perspective. And also this whole thing, the Authenticator, and remember that Authenticator is using hardware security modules in the device, in my iPhone, in my Android device, in my Windows PC. So this is very strong. So it is a very strong authentication. And again, remember, it's still multi-factor. It's something I have, and then it's something I am or something I know. So it's a very strong authentication we are performing here. But I've glossed over something at a pretty massive level. One of the things I talked about was proximity. This all-important proximity that stops some of these phishing type attacks. How does that work? How am I proving the proximity between my authenticator and the client I'm using? For example, maybe this is my iPhone and this is my PC. How am I proving that? Well, sometimes the authenticator is in the client. Hello for business, there's a TPM, it's in the machine. That's the end of it. Nothing else is required. I'm just really using WebAuthn. But if I'm using an external authenticator from the device with the browser, that external authenticator has its own sensors, like the biometric sensors. It maybe then connects via some protocol. So I'm thinking here, okay, well, how is this now working between this client and the authenticator? Maybe it's USB. Now, in that case, it could be, for example, one of these type keys, because again, I can still store passkeys, FIDO2 credentials on these types of USB device. It could be near-field communications. So obviously, a USB is a physical connection. Near-field communications, well, near-field. I have to be within a certain proximity. Bluetooth. So these different, and that only works within a certain distance, and I can detect certain strengths in that. And so the way this is enabled, this part, this is CTAP. CTAP is Client to Authenticator Protector. CTAP is the thing that is proving this presence, that is proving this proximity. It ensures, hey, I do have this physical presence to allow me to leverage this. And CTAP is the other half. When we think of FIDO v2, FIDO v2 fundamentally, if I look at this, FIDO v2 is WebAuthn and CTAP. Those two specifications power FIDO2. Now, again, I don't have to use CTAP if it was native to the client, like Hello for Business, but most scenarios we are going to see, passkey is very often going to be our phone. Again, sometimes it's going to be in the device. Very often we use the phone. That's where I use CTAP for that. Now, Bluetooth is going to be the most common one. Again, we have our phone. Bluetooth is not super reliable as a transport mechanism. And so what we're commonly going to have with Bluetooth, we're also going to use HTTPS. Now that can work over the internet, over whatever network I'm on between my device and the client. And so here what we actually are doing is hybrid. So it's using Bluetooth to prove the proximity. And then once that's been proven with Bluetooth, then the actual communications will go over HTTPS. And so all of this enables cross-device authentication, or CDA. And that's going to be by far the most common scenario you're going to see. Hey, I'm going to add a passkey on my phone, and then I can use it cross-device. I can use it on many different devices. And that's the key part, CTAP with the WebAuthn. So, FIDO2 v2 passwordless credentials or passkeys, this is what this is two standards. WebAuthn, that's always used. That's powering the nonce and the cryptographic operations. And then CTAP, Client to Authenticator Protector, if I'm ever using an external authenticator, which is going to be very, very common. These passkeys, I have a different passkey for every site I visit. I don't have a passkey that I'm using for all of the different sites. Remember, the whole point, is the passkey validates the URL and the relying party ID. So when I think about my passkey, a key element of this is one for every unique combination of these tuples. So for every user account, for the relying party, i.e. the site I'm using, and the authenticator. Those three things make up the tuple that is your passkey. That's the point. So I don't have a passkey that I use everywhere. No, because then I wouldn't have that nice protection from someone trying to use the passkey and trick me. It's unique. I have a passkey for every one of those unique sites, every unique relying party, every unique account. That's the goal. And I'll have a new passkey created for each unique combination of those. And they are discoverable. So one of the nice things we'll see is when I go to a site, when it performs this GET, the WebAuthn client, it can discover what passkeys I have and show me the ones that match. So, hey, this is the relying party ID. I've confirmed it really is this URL. Which passkeys do you have for this relying party ID? It will show them and I can just select it. And as you've gone past that first time, then it will just make it even simpler going forwards. Now, the next part is I talked about the Authenticator. And I said, okay, the Authenticator is very strong. There really are two types of Authenticator available to me. So I can think about the idea that we have first party. So a first party would be something like the iOS keychain. And obviously Android, something native on the device. Third party is some other authenticator I've installed on the device. For example, Microsoft Authenticator. And there are others. For all of these, there are other first-party and third-party authenticators. So we have different authenticators. And then we have two types of passkey. Now, I really want to stress the difference between the authenticator, that container for the passkey that performs the various operations, and then the passkey itself that is in and is acted upon by the authenticator. So we have different authenticators. And then for the passkey itself, there are two types of passkey: device bound and synced. And this is an important point. And I don't think one is better than the other. There's definitely different friendliness aspects to them. So if I think device bound is fairly obvious when you think about what that is. So device bound it cannot leave the device. It cannot leave the authenticator. The passkey cannot leave the authenticator. So this would be something like, hey, it's stored on a USB. It could be, hey, it's stored in the TPM of a device. It could be like Microsoft Authenticator, and it's using the hardware. And with the device bound, if I'm a corporate organization, for example, and I'm the administrator of that identity system, I might like the device bound because I might like to know exactly where that passkey is. It may be important in certain scenarios. But from a friendliness perspective, if it's only stored in this one authenticator and I lose my phone, I've lost the passkey. Now, in a corporate environment, let's say I'm passwordless. You're like, now what do I do? Well, your administrator would create a temporary access pass, that one-time pass. That would bootstrap your authentication process. I would then go and create a new passkey in my new phone, and I'm back up and running. For corporate, might be fine. But now think about consumer scenarios. It just wouldn't work. And so, or a key can be synced. And exactly as the name suggests, when I'm doing the syncing, it syncs to some cloud service. Now, stewardship is still a key goal. I still want a certain party to be stewards for those passkeys. One entity is responsible for protecting the private key. And that entity is going to make promises about keeping that key secure. And so what that realistically means is while they're synced to some cloud service, it's always within a specific ecosystem. I.e., I can sync my passkey within the Apple ecosystem. iOS to Macintosh, my iPhone to my iPad, all going to work fine. Not to an Android, not to a Windows. Android to Android, Windows to Windows. Yes, because the stewardship is Apple, the stewardship is Android, the stewardship is Microsoft. So I want a party responsible for the stewardship of the key. And so if we do synced, yes, you'll see them available to all my different, in my case, my Apple devices. I can see it on my iPhone, I can see it on my iPad. I won't be able to see it on my Android device. So I can do synced, but it's going to be within that specific ecosystem. And for the average consumer, a non-technical person, this makes way more sense because now I don't have the fear of losing the device and now I'm locked out forever. If I lost my device, I get a new device, it will sync back down from my cloud service. It's also going to be simpler because, hey, I'm using this site. I'm now using the site on my other device. Hey, I've already got the passkey. I'm not going to go and create another passkey. Now, if it was device bound and I go and access the site from another authenticator, I just get another passkey. I can have more than one passkey because remember, I have this unique tuple of the user account, relying party, and the authenticator. It's just that if it's synced, well, then I can bring the key down to multiple authenticators. And that's the key point. And for the most part, in consumer, it's always going to be synced. You would never, I don't think, have a device bound. In the enterprise space, it's going to vary depending on what maybe regulations you have, what confidence I want to have exactly where that passkey is. But again, I think over time, you'll see more and more sync there. Maybe there'll be some device bound. It's going to vary. Now, huge thing I want to stress here because it's going to get confusing. This is the key. Is the key bound to a device? Can the key be synced to another cloud service? That is not to say the authenticator that's storing the key can't roam, because this absolutely can roam. My iPhone with a device-bound key, I can authenticate against this computer and that computer as long as it has the proximity. So the key is not leaving the authenticator, but the authenticator can be brought into presence of different machines, and I can use the passkey from it. So while the passkey in these scenarios isn't roaming, the authenticator absolutely can roam. Hopefully that makes sense of difference. Passkey isn't leaving and bouncing around different places. I'm not copying that key all around, but the authenticator can be used to roam and connect. Where can I use this? Pretty much everywhere. Any consuming web-based API can leverage this. Now, generally, it's always going to be via a browser. Even if it's an application, it will trigger a browser to do the sign-in experience and create the passkey. I'll bring up a page, and then I can go and get the token and use it in my app, whatever I want to do. On Windows, it's actually Windows 10 and Windows 11 doing the storage, doing the work, not the browser. The browser basically just calls the OS functions. And that also therefore means different browsers on the same machine would have access to the same passkeys. On other platforms, it might be the browser has implemented the WebAuthn client. But doesn't matter. I can use the passkey on generally any machine where I can do the proximity. So that cross-device authentication does work across ecosystems. Hey, my iPhone can help authenticate me on my Windows machine or whatever that is, because that's just the CTAP happening. It's only if I'm doing the synchronization, it has to stay in the same ecosystem, but I can always use it wherever I want. The point is this is super user-friendly. That's the whole goal around this. And just in case it's not clear, okay, you've gone on about this. What's different than what we used to do with the Authenticator app? Again, the Authenticator app would display a number that the user would type in. Yes, it showed the app that was requesting it would show location, but it relied on human cognition to say, is something wrong here? So it was susceptible to social engineering. It could be phished. The Authenticator app wasn't doing any checking on, oh, okay, it's saying it's this, is this URL really matching this thing? It wasn't doing those checks. It was a proprietary mechanism. Whereas now with the passkeys, this is a standard. FIDO2 is a standard. WebAuthn is a standard. CTAP is a standard. The use of the nonce is a standard. There's no reliance at all on human cognition anymore. It's the WebAuthn client is doing the check. Is this site they're visiting actually the relying party? Is their authenticator actually close to the machine that's trying to do the authentication? There is no credential. Hacking, really not that useful. And it's super strong using the platform capabilities. And again, we have the different flows. The first time it's going to go and create the passkey. First time I use it, it might ask me where this is. Second time, it gets just better and better. You get a more and more guided process through this. But it's going to be a consistent experience. When I use passkeys, it's always the same experience, whether it's Entra, a Microsoft account, a Google account, an Amazon. It doesn't matter. Passkey is a standard. I'm going to get a consistent, very, very user-friendly experience. So let's talk then Entra. And let's actually see some of those things and the Microsoft account. So today, if I want to use this with Entra, so I have my Entra tenant. Today, and I'm really going to harp on this point, I use the Microsoft Authenticator app. And today, it is device-bound only. But, so today at time of recording, it's device-bound only. But Microsoft have stated in the roadmap soon will be syncable. So yes, they'll be synced in the future. Today, it's not, but it's definitely coming. But just understand for today, it's going to be a device-bound. So it's the Authenticator app only. And what I require is Android 14 plus or iOS 17 plus, because it relies on capabilities of the underlying operating system to power all of these things. Now, every single type of key has something called an AA GUID. Everything. So the iOS Authenticator app has an AA GUID. The Android has an AA GUID. A certain brand of a particular model key has a certain GUID. A different model from the same manufacturer has a different AA GUID. Windows Hello has an AA GUID. And that enables you to uniquely identify what type of authenticator is being used. So that may be really important to me as an organization. I may only want to allow certain types of authenticator to be used. I may hear about some vulnerability in a certain authenticator and want to block it. So we have complete control as the administrator of our tenant on which GUIDs we want to use. Now, Microsoft publish the particular AA GUIDs of their authenticators. So if we go and look over here, I can see the AA GUID for the Android and the iOS apps. And I need to enable those. So step one, if I want to use passkeys in my Entra tenant, is I would go to protection, authentication methods, and then policies. Under policies, I'm going to select, now today it says FIDO2 security keys, which is what these are, remember. You never know, they may rename this to passkeys, I don't know. We're going to select FIDO2 security keys. We can enable it for all users or groups of users. We could exclude certain users and groups of users. Then we go to configure. Now at time of recording, important point, I need to not enforce attestation. That will change at GA. Today I turn off the attestation. And what I'm doing here is I'm restricting it to specific keys. So I'm only allowing the ones that I specify. And I've entered in those AA GUIDs for the Android and the iOS Authenticator apps. So now that means a user will be able to go and sign up for those. And that's really it. So on my Entra tenant, I've done the work. So as a user, I could just hit add a new sign-in method. And what we'll see now is this option of a passkey. And you can see for this user, I already created it. So we can see down here, I have a passkey, and there's that AA GUID of the iOS Authenticator app, and I can see the registration. I can also register it directly on the phone, and the documentation walks through this in huge amounts of detail. So I'm not going to walk through all of that stuff. That's not particularly interesting because it's right there. So, okay, how do we use it? And I want to show the usage, I guess, in two different scenarios. So there's the usage scenario where I'm on the same device. So for example, I'm on my phone, and on my phone, which is where the Authenticator is as well, I try and go to a site. That's going to be one experience. Then the other experience is where I'm using this cross-device authentication. So I'm on my PC trying to access a site. I want to use the passkey on in my case, my iOS device. So what we're going to do is I'm going to open up my little iPad mini. And what we will do here is I'm going to share my screen to the app, and we can walk through both of these little scenarios. So if I open this up, there we go. All right, so now you can see my little iPad. And you can see currently I've actually got two things, right? I've got my Entra, and you can see here I've got my passkey available. So I've got a passkey right here on the screen. So you can see it's only available on this device. So this is not synced. This is a device-bound passkey. Now, the other thing you can see on this device is I have a passkey for a Microsoft account. Now, this passkey, as you'll notice here, is being stored in the iOS keychain. So this is going to be synced, but we can see it's for a particular website. So I just wanted to show you that on this device, I actually have two different passkeys. I have one in the Authenticator app for my Entra, and then Clark has one for their Microsoft account in the iOS keychain. Now, if I go to an in private window, and let's just try and go to a site. So if I go to myapps.microsoft.com. Now we get the normal authentication experience right here. But notice what we have is this ability to have sign-in options, which is what I'm going to drive. So I'm not going to enter an email address or anything at all. I'm going to hit sign-in options. And notice it's giving me the option of face, fingerprint, PIN, or security key. I like that. And now it's checking. And notice what it's showing me. Now it knows what site I'm trying to access. It knows I'm trying to access login.microsoft.com. So it's discoverable, remember. It's showing me all of the passkeys for login.microsoft.com. Now, one of them is in the Authenticator app because that's my Entra account. And then it knows there's two others that are in the iOS, the keychain, for Clark and myself. So it's only showing me the ones that match the fully qualified domain name, the URL, where it matches the relying party ID of the passkey. So I can't be phished, I can't be tricked. Now I'm trying to access an Entra site, so I'm going to make sure I use my Entra credential. So I will hit continue. This point, the biometric check. Yep. Do I trust it? Yep, sure. I guess for now. And now you can see I'm in. So that was using the passkey locally on the device. Okay, great. Now let's take it to the other scenario. So I'm going to close that little tab down, go back over here. So now what I need to do is I'm going to try and access a site on my computer. So we'll jump over to a private window here. And let's go to the same site. So we'll go to myapps.microsoft.com. And we're going to do the same thing. We'll say, hey, sign in options. We're not going to enter a username or anything. I'm going to do again. Remember, consistent experience. This is exactly the same as what I saw on the iPad. It's doing a check. It's looking around. Now it's saying you've got some passkeys here. Do you want to use them? But I'm going to say, actually, no. I want to use another device because I'm trying to show you the cross device. It's saying, hey, do you want to use an iPhone, iPad, or Android? Yes, yes, I do. Now remember, at this point, I would have to have Bluetooth enabled on this PC and on the iPhone because that CTAP has to prove that proximity by Bluetooth, and then it will just talk HTTPS. So now it's showing me this QR code that I have to scan in. So if we jump over, so I'm looking at my iPad, sign in. So now on the iPad, what do I want to use? Yes, I'm going to use Clark again, confirm. It's still going to make me do that gesture, that proof. So proof of intent. And then the rest of it carries on again. No, don't want to stay signed in. And I'm here. So this time, as we saw, hey, that was that cross-device authentication. I did the QR code, and I've authenticated. So it used the Bluetooth to prove the proximity. The presence is there. I'm not hundreds of miles away. Then it carried on the conversation on the HTTPS, and I did that authentication. So we saw both scenarios, locally on the device using the passkey and cross-device, Windows with the passkey on iOS. And you saw it just working. So, and you saw how consistent it was and really how simple it was. And that's the whole point about this. It is discoverable. It shows me the ones where the relying party ID of the passkey matches the relying party ID it's asking for, which has to match the URL because the WebAuthn client is going to check that. So it's a very simple user experience. Hey, do you want to use this one? Yep. And I'm up and away. Just very, very quickly, so that was Entra, okay. What about Microsoft accounts? So remember, a Microsoft account is used by consumers. What is going on here? Okay. A consumer is not going to understand the concept of the device bound. It's going to be too complex. They lose their device, they're stuck. And so if we go back through, okay, board's woken up. So remember, with Entra, we would have to go and agree what AA GUIDs we wanted. Check. Now a Microsoft account. Now a Microsoft account is for consumers. Consumers want safety. They don't want to risk losing the passkey and getting potentially locked out. What that means is it has to be synced. So Microsoft account passkeys will always be synced. I can use platform native ones. I can use third party. I can't actually use the Authenticator app. The Microsoft Authenticator app cannot be used from Microsoft accounts. I suspect that's because the Microsoft Authenticator app today is device bound. I don't want that with a Microsoft account. I don't know, may not be it. I suspect that's what it is. So I can use iOS Keychain, which is what you saw I had for Clark. I can use third-party solutions. So LastPass, Authn, NordPass, KeyPass, the list goes on and on. I can use Android. I can use the iOS ones. Just cannot use the Microsoft Authenticator app, which is commonly not used by consumers today anyway. But the rest of it will work exactly the same way. It's a passkey. I'm not going to see any difference in experience between Entra and a Microsoft account. I can use that on Office, OneDrive, Xbox, Skype, Copilot, Edge. It's a passkey. It's going to work across all of those different things. And the experience in using it is exactly the same. My enrollment, I would enroll like I do any other credential. I can actually go to aka.ms/add-proof for my Microsoft accounts and then go and add a passkey to it. Now, as you saw, I already added a passkey on this particular device. And so what's the most challenging scenario? I guess what we could do is we could do the remote one again. Obviously on the device would be a lot simpler. But if we this time go to, let's open up our private browser and let's do a new tab. And what we'll do, so let's this time, so I'm just going to go to the account.microsoft.com. So that's my consumer. I'm going to say sign in. And again, it's the same experience. Oh, look, there's my sign in options. So I'm going to say sign in options, security key. Once again, it's showing me the local ones, but I say use another device. Yes, I want to use my iPad, Android, nothing changing at all. There's the QR code. If I open up my camera again, just to prove I'm doing it. There we are again. Sign in with a passkey. There we go again. It's proof to presence. But this time, well, I'm going to select my personal passkey, because obviously this time I don't want to use my Entra account. And I can see this time it's right there. I have to do the same gesture as before. So I'm doing an Authenticator gesture. And at this point, hopefully it will sign me in. Once that completes. But that was now that cross-device authentication again. But this time I'm doing it for a Microsoft account. Do I want to stay signed in? No. But hey, I'm in. It's going to go and show a bunch of random stuff I don't care about. Setting up other stuff, blah, 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 blah. But you saw it was exactly the same. There was no difference in the experience. And that's the point. We want this to be super user-friendly. We want it to be very easy. Yes, there's a massive amount of stuff going on behind the scenes. There's powerful cryptography, there's private public keys, there's WebAuthn taking these nonces and signing them. There's the client checking, does the URL match the relying party ID, which has to be a subset of the URL of the site I'm currently visiting. I have to do that intent, the biometric, the PIN. But that's all transparent to the user. All of these things along the way are protecting the user from phishing, from a man in the middle trying to go to a different site, from trying to trick me and the social engineering to authenticating for them, to hacking the site. Well, now it's just got public keys there. There aren't any passwords that the user might use on multiple different sites. There's one compromised. They're all compromised. It's super strong. I'm using the hardware security capabilities of the platform. The user has to have intent. That's a core tenet and a core promise of everything about this. A biometric, a PIN. I have the device, so it's multi-factor. Device bound, I may want that for some scenarios. Synced is going to be far more friendly for the average consumer. I can specify the types of authenticator I want in my environment by specifying the specific AA GUIDs. Or I could just block specific AA GUIDs if they had some compromised. For consumers, it's always going to be synced. They're never going to want to deal with device bound. Microsoft accounts can use all the native capabilities of iOS and Android. I can use third parties. I just can't use the Authenticator app today. It's just a passkey. I could delete them if I wanted to. Like, again, I would delete any other authentication method, both on Entra and Microsoft. But this is the direction. I think what we'll see is they'll all become these passwordless FIDO2 credentials or passkeys. And it really is very easy for the user to leverage them. It protects them from the self, and it really is just goodness. So I would encourage to take a look. If you've not tried them out yet, go and have a look at them. See if they fit your requirements. See how it maybe improve the user experience. And as always, I really hope this was useful. Until next video, take care.